Okay, so in this video we're going to go over the quadratic equation and how to use it and when to use it. So, how to use quadratic equation. Okay, so first, what is the quadratic equation? It is an equation that we use to find the roots of a quadratic function. So, we've solved x in terms of all the constants. So, well, they're not constants, the coefficients. Negative b plus minus b squared minus 4ac all over 2a. That is the equation, quadratic equation. Now where do we get all these letters? They are from the quadratic function in standard form. ax squared plus bx plus c. So a, we take it from the first, or the number in front of the x squared, b is from in front of the x, and c is just your constant. Okay, so now what if we have this function and we want to solve for it? 2x squared minus 7x minus 4. Okay, we can use the quadratic equation. We can factor this as well, but we'll use a quadratic equation. That's when y equals 0. X equals negative b. So negative b is positive 7. Plus minus the square root of negative 7 squared minus 4 times a is 2 times c is negative 4. All over 2 bracket times 2a. Okay, times 2. So now we have x equals positive 7 plus minus 49. And then we have 4 times 4 is 16 times 2 is 32. And there's a negative here, so it's plus 32. And then 2 times 2 is 4. Now we have x equals, and now that's 81. So 7 plus minus the root of 81 all over 4. And this is x equals, that's 9. 7 plus minus 9 over 4. So then if we had the two cases, we have, so 7 plus 9 over 4 is 16 over 4 is 4. Now the other root is x equals 7 minus 9 over 4 is negative 2 over 4 is negative a half. So we've just solved for these two roots. And what does this mean? Let's look at the graph. So what are the roots? Okay, so our graph, it opens upwards. So here, our first root, let's say at when x is 4, so let's say 4 is here. This is a point on our graph. It is a root. And then the other one is at negative a half. So we could find the vertex. I'm not going to find the vertex, but there's something we could do. It will be down here. We know that our y-intercept is at negative 4. Let's say negative 4 is around here. So we know that the graph, and we know that a is positive, so it opens upwards. It's going to go like this. So here's y and x, and we know that it's going to have a minimum halfway between these two roots. So the minimum is always halfway between the roots. I'm going to just try and draw this. Let's get this up there. Okay, that's pretty good. And here's our vertex is right here. So we could actually solve the vertex. We know that the x component of the vertex is negative b over a, 2a. So let's do this. Ex is negative b over 2a, which is then just 7 over 2 times 2 is 4. So that is 7 over 4. And the y component, we'd have to solve that. We'd substitute that back in here. And we'd just resolve that. I mean, we could do it. I don't find it particularly fun. It's just going to turn into a random number. So we'll leave that. But you just substitute that in. So we can even put it as the function of 7 over 4. And that'll give us our vertex here. And this 7 over 4 is exactly halfway between the two roots. It is our axis of symmetry. And that's why we use the quadratic equation when we want to find the roots, and the function doesn't look very factorable.